Many limits can be found by simply substitution. For example, page 118, exercise 18. The limit of x squared minus 25 over x squared minus 5 as x approaches 3. We evaluate this by simply replacing x with 3. The limit of x squared minus 25 over x squared minus 5 as x approaches 3 is 3 squared minus 25 over 3 squared minus 5, replacing all x's with 3. 9 minus 25 over 9 minus 5, which is negative 16 over 4. Negative 4 is the answer. Exercise 26. The limit of x cubed minus 8 over 2 minus x. We can't do this problem the same way because when we replace x with 2, we get 0 in the denominator. 2 minus 2 is 0. It is impossible to divide by 0. So we use algebra. X cubed minus 8 can be factored. It's the same as x minus 2 times x squared plus 2x plus 4. And 2 minus x is the same as negative 1 times x minus 2. So the x minus 2 in the numerator and the x minus 2 in the denominator cancel. Therefore, we have the limit as x approaches 2 of x squared plus 2x plus 4 over negative 1, because these are gone. And now we finish this by replacing x with 2. The limit is 2 squared plus 2 times 2 plus 4 over negative 1. We find the value of this limit by just replacing every x with 2. That's 4 plus 4 plus 4, all divided by negative 1. So negative 12 is the answer. Exercise 28. The limit of 9 minus x over the square root of x minus 3. X is approaching 9. So once again, replacing x with 9, we get 0 in the denominator. Dividing by 0 is impossible. So we're going to do an algebraic strategy called rationalize the denominator. That means we're going to multiply the denominator by its conjugate, radical x plus 3. If we multiply the denominator by radical x plus 3, we have to multiply the numerator by the same thing. If we multiply the numerator and the denominator of a fraction by the same thing, then we can say these are equal. And in the denominator, radical x minus 3 times radical x plus 3, we multiply those by FOIL, we get x minus 9. And that numerator, I'm going to rewrite this numerator up here as negative 1 times x minus 9 times that red radical x plus 3. Now the x minus 9 in the numerator and the x minus 9 in the denominator cancel. So we're left with the limit as x approaches 9 of -1 times radical x plus 3. That's all, because these are gone. And now we can find this limit by replacing x with 9. The limit is -1 times radical 9 plus 3. So -6 is the final answer. On page 128, exercise 16 says f of x equals x squared minus 3x plus 5. And the directions are to find a simplified form of the difference quotient. The phrase difference quotient means f of x plus h minus f of x, all divided by h. This fraction here is referred to as the difference quotient. And that red part, f of x plus h, means replace every x with x plus h. So there's the function that's given, but every x is replaced with x plus h. Instead of x squared, it's x plus h squared. Instead of -3 times x, it's -3 times x plus h. Plus 5 is just stays that way, plus 5. Just the x's are replaced with x plus h. After this minus, there's this green f of x. That just means what's given. F of x is what is given. X squared minus 3x plus 5. But it's minus all of this green. Parentheses required. And we just simplify this, and we'll be done with this exercise. We square the x plus h by FOIL. That comes out to be x squared plus 2xh plus h squared. That's x plus h times x plus h. The -3 gets distributed. -3x, -3h. The plus 5 gets copied. And this minus in front of the green gets distributed. Minus x squared. Minus a minus, so that's plus 3x. And minus positive 5 is -5. All over h. So we've gotten rid of all the parentheses by FOILing and distributing. And now we look for like terms. X squared minus x squared is nothing. 2xh gets brought down. H squared gets brought down. -3x and positive 3x is 0. -3h gets copied. Plus 5 and minus 5 is 0. So all over h means each of these terms gets divided by h. Or the h that's in every term can get factored out. And then this h in the numerator and this h in the denominator cancel. So the final answer is 2x plus h minus 3. That's called the simplified form of the difference quotient. Exercise 30 says a of t equals 2,000 times 1.2 1.015 raised to the 4t. 4t is the exponent. Part A says find a of 3, which just means replace t with 3. If I replace t with 3, this exponent becomes 12. Calculate this with your calculator. 2,000 times 1.015 raised to the 12th power. That comes out to be about 2,391.24. And A is an amount of money, so we'll put a dollar sign there. Part B is find A of 5, which just means replace t with 5. Replacing t with 5 makes this exponent 20. 4 times 5 is 20. Calculate that with your calculator. 2,000 times 1.015 raised to the 20th power is $2,693.71. Part C, A of 5 minus A of 3 means take the answer we got in part B minus the answer we got in part A. And we get $302.47. Part D, A of 5 minus A of 3 all over 5 minus 3. So this numerator is the answer we got in part C. And the denominator is 5 minus 3, which is 2. When we divide these, we get approximately $152.24. And since the A is an amount of money, and the numbers in the parentheses are t, t is time measured in years, that means this number means that the amount of money, this is in a savings account, increased at a rate, this is the important word, of $152.24, because that's the numerator. Per is a translation of this line right here. Year, because the number underneath this line is a number of years. And I need to throw in the word average. This is the average rate. The amount of money increased at an average rate of $152.24 per year for the time period 3 years to 5 years. I'll say from year 3 to year 5. On page 142, exercise 16, it says f of x equals 2 over x. And the directions are to find f prime of x. The definition of this, f prime of x, this is the definition. It's the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. In other words, it's the limit of what we called the difference quotient a little while ago. It's the limit of the difference quotient as h approaches 0. And this thing, symbolized f prime of x, is called the derivative of the function. This is the definition of the derivative. So say it's the limit as h approaches 0. This red, f of x plus h, means whatever function is given with x plus h in place of x. It's the given function with x plus h in place of x. Instead of 2 over x, it's 2 over x plus h. And after the minus, this green f of x, that is just the given function. We're going to multiply this numerator, which is red and green, by x times x plus h. We're going to take x times x plus h times each of these terms in the numerator. That means times this red term. And we're going to multiply the same thing. X times x plus h times that green term. And the thing about fractions is if we multiply the numerator by this purple, we have to multiply the denominator by the same thing. So f prime of x equals the limit as h approaches 0 of 2x minus 2 parentheses x plus h all over this purple and black. I'm just going to copy. So what happened here is this x plus h cancels with this x plus h. And 2x is left over. After the minus, this x up here cancels with this x down there. And this is what's left after the minus. And the bottom is just copied. So f prime of x equals the limit as h approaches 0 of 2x minus 2x minus 2h all over x times x plus h, because I just distributed this minus 2 to remove the parentheses. Notice the denominator, I'm just leaving that alone for now. So f prime of x equals the limit as h approaches 0 of negative 2h over x times x plus h times h, because 2x minus 2x is 0. So f prime of x equals the limit as h approaches 0 of negative 2 over x times x plus h, because the h up here cancels with this h down there. Now I calculate this limit by replacing h with 0. F prime of x equals negative 2 over x times x plus 0. Just replace h with 0 because h is approaching 0. So f prime of x equals negative 2 over x squared. That's the answer to part A. Actually, it's the answer to part C. We did not do parts A or B. Exercise 19, which is the last one in this video, is to find an equation of the tangent line to the graph of the function we just worked with at the point 1, 2. No, at the point 1, 2. Well, first of all, the derivative of that function is what we just found in the last exercise. The derivative is negative 2 over x squared. When we calculate that at this x value, when we calculate the derivative at a specific value of x, in this case 1, the number we get is called the slope of the tangent line. At, in this case, when x is 1. And the equation of a line is always y minus y1, which is going to be, the y1 is going to be this number, equals m, that means the slope, parentheses x minus x1. x1 is this number. The equation of the line tangent is y minus y1 is 2. M means the slope. The slope means the derivative. That's what we calculated right up there. Parentheses x minus 1, because it's at the point where x is 1. When x is 1, y is 2, and this number is the slope. So y minus 2 equals negative 2x plus 2, distributing. Add 2 to both sides, and that is the equation of the tangent line. Two f of x equals 2 over x at the point 1, 2. This is what that looks like. F of x equals 2 over x is blue. The answer we just got, y equals negative 2x plus 4, is red. We call this line the tangent line. Tangent means touching. The line is touching. F of x equals 2 over x at 1, 2. Tangent or touching.